You are halfway through installing a fresh operating system when the progress bar stops. The screen locks, and the installer remains completely unresponsive. On legacy hardware like this Intel i3 processor, these hard locks look like the typical symptom of a CPU outmatched by modern software. The failure is actually happening on the PCIe bus. A hidden hardware conflict is generating a massive error storm that crashes the system in the background. We'll find the component using logs, bypass the storm to finish installation, and apply a permanent driver blacklist. Learning this diagnostic process prevents perfectly capable legacy hardware from being unnecessarily thrown in the trash. When the graphical installer freezes, press Ctrl-Alt-F2 to switch to the background TTY console. Run the top command to check the system load. A load average exceeding 4.0 confirms the processor is being completely maxed out. Now use dmessage/tail to see the kernel's most recent activity. This repetitive wall of PCIe warnings points directly to a Realtek Wi-Fi module as the source of the system stress. Hardware components use signals called interrupts to get the CPU's attention. We can view a live count of these signals by checking the system's interrupt file. Under the AER counter, these advanced error reporting interrupts are skyrocketing by tens of thousands per second. The faulty Wi-Fi card issues so many false alarms that the CPU stalls, becoming too busy handling interrupts to process the installer's code. To get past this, hard reboot the machine and pause at the initial grub boot menu. Press the E key to enter the edit mode for your boot parameters. Find the line starting with Linux/Casper/VM Nunes. Type PCI equals no error right before the 3 dashes at the end of the line. This parameter commands the kernel to ignore advanced error reporting interrupts entirely, muting the hardware errors so the installer can function. Press Ctrl-X to boot. With errors suppressed, the graphical installer now flows smoothly to completion. While this gets the OS installed, the physical hardware flaw remains active. We still need a permanent solution once the system is up. When you first log into your new server, the system will appear perfectly stable. Ubuntu Server defaults to leaving unconfigured Wi-Fi interfaces in a powered down state, which temporarily stops the hidden error storm. We can confirm the Wi-Fi card is the problem by forcing it to turn on. Type IP link set WLP1S0 up. Pull up the live interrupt log watcher immediately after running that command. The very moment the driver activates and attempts to find a wireless signal, the catastrophic hardware error loop instantly restarts and crashes the system. This confirms the Wi-Fi hardware is fundamentally compromised. Using this card for networking will result in unpredictable server crashes. Stop the error storm immediately by unloading the network module with sudo modprobe-r RTL8723BE. To prevent this driver from ever loading again during a reboot, we need to create a persistent blacklist rule. Run this command to write the blacklist rule into your system's configuration directory. For a reliable home server, a wired Ethernet connection provides a much more stable architecture rather than relying on a failing Wi-Fi module. Reboot the machine and check your interrupt logs one last time. The counter should now sit at 0. Surgically removing software access to the damaged physical component ensures the server's long-term operational stability. We have successfully stabilized an operating system on hardware that initially appeared to be fatally broken. This fix was found by looking past the frozen GUI and diagnosing the invisible PCIe storm through the kernel logs. This is the primary rule for Linux troubleshooting. Always verify the raw system data before giving up on legacy hardware. Mastering command line log diagnosis allows you to transform a seemingly useless PC into a powerful, reliable server asset. If this breakdown helped you save an old machine, like the video, subscribe to the channel, and stay tuned for more deep dive hardware troubleshooting tutorials.